Hello, Honors Algebra 2, Period A, Period C. Here's our video for homework number 380. And as you see on the board, it's page 380, 13 through 20. Now, I showed you this lesson during our Zoom conference today on Friday, but many of you asked if we could do a video as well, which I think makes sense. So here's our video, but first check out this hat. And if I asked you what hat logo it is, you'd probably say the New York Yankees. Kind of looks like a Yankees hat, but it's actually a replica of the hat that I wore when I played baseball at the University of New Hampshire. So that's actually an N and an H. But I wanted to start the video with something from my house or a joke, and that's the best I came up with today. So here we go. All right, so here's the lesson, page 380, 13 through 20. And it's going to say, find the nature of the roots. And what that means is find how many positive, negative, and imaginary roots. We did nature of roots before, but it was, two real roots, one double real root, two complex roots. It's sort of like that. But here it's going to be how many positive, how many negative, and how many imaginary roots. I can show you that graphically. I know some of you live in New Hampshire, and the University of New Hampshire no longer has baseball. Went from Division I baseball to no baseball at all, which is a shame. This would be a cubic equation. In another lesson, we'll tell you the shape of cubic equations and quartic equations and so on. But this is cubic, and it has the following roots. There, there, there. So this would have 2 negative and 1 positive. You can only have a total of 3 because it is cubic, so there'd be no imaginary here. 2 negative, 1 positive. Okay, that's easy enough. How about that one? I can tell you it's cubic, it's an x cubed, and the only place it crosses the x-axis is here. So that's 1 positive. Doesn't cross on the negative side, so it's no negative. Well, it's still going to have 3 roots. So far we got a total of 1. So the other 2 roots are 2 imaginary. You're not going to be doing this by graph yet. You're going to be doing it by another method, but I'm just teaching you the graphic background. Let's look at 2 more. This would be a 4th degree equation. It would be x to the 4th. It's called a quartic, x to the 4th. And it has 2 negative roots, 1, 2, and 2 positive roots. 2 pos, 2 neg, 0 imaginary, because why? Because 2 negative, 2 positive add up to 4, and we can't have more than 4 with the 4th degree equation. One more. That one's interesting. That's also 4th degree. It would have 1 negative, 1 positive. That's only totals 2, and we need a total of 4, so that's 2 imaginary. Okay, so 1 positive, 1 negative. That leaves 2 imaginary. So that's what we're going to be doing, but we're going to do it more algebraically rather than graphically. So here's how it works. So we take our equation. That's a cubic equation, so we need a total of 3 roots total. We're going to find out how many positive, how many negative, and how many imaginary. Here's how I find out positive. It's the number of times the coefficient sign changes. The number of times the coefficient sign changes. It starts positive, goes to negative, that's 1 change. Goes back to positive, that's 2 change. Goes back to negative, that's 3 changes. So it has 3. 1 change, 2 change, 3 change. Now here's the thing, it could have 3, but it also could have 1. I don't know if I can draw that picture here. Let's see. Could be like that, where it has 3. But it also could be like this, where it has 1. Those are the same kind of cubic equations. They're shaped like that. See, this has 3 positive roots. That one has 1. We have a couple negative. So we have to consider 3 or 1. All right. Now, how do we do the negative roots? To do the negative roots, we take f of negative x, which means we replace each x here with a negative x. It's going to look like this. Negative x cubed, negative x squared, negative x. So each x here got replaced with a negative x. Now when I do that, negative x to the third power is negative 1x cubed times 2 is negative 2x cubed. Negative 1 squared is positive 1 times 3 is negative 3x squared. That'll be negative 4x minus 5. Negative 1 to the third power is a negative times 2 is a negative. Negative 1 squared is a positive times a negative is a negative. That's a negative. And the constant's a negative. So how many sign changes now? None, none, none. 0. So the number of negatives has to be 0. So now what we do is we make combinations, sort of like ordered pairs. We give 3 positive and no negative, 1 positive, no negative, and then the imaginaries will fill in the rest. So let me make a little chart, a little table. So we said we could have 3 or 1 in the positive, but no negative. So we could have 3 positive and no negative. It's like matching 3 with none. We could have 1 and none. But we have to have a total of 3 roots. It was a cubic, so we have to have a total of 3 total. So if that's the case, that means there's no imaginary there, because we already had 3. And that's the case, we have 2 imaginary there. So this first graph with the 3 positives was like that, and the second one would be like this. Nope, not like this. Like, I don't know what it'd be like. It'd be like that. Here we go. 3 positives, 1, 2, 3, no negatives. 1 positive, no negatives. There must be 2 imaginary. Again, you don't have to do the graphs, but seeing the graphs I think makes it a little bit helpful. Let's do another one. Okay, this is a quartic. It's a 4th degree, so we need 4 total roots. And I know we have no x cubed term there. We don't have to worry about that at all. So positive, how many sign changes do we have? 1, 2. Right? There's a change from positive to negative. That's 1. Stays the same. That's 2. So it's 2 or 0. I should have said this before. Whatever we get here, the other possibility is that number decreased by 2. So a minute ago when we said 3 or 1 is 3 or decrease it by 2. 2 or decrease it by 2. If we had 6 here, we'd have 6 or 4 or 2 or 0. How about the negatives? F of negative x. Replace each x with negative x. And let's see. A negative to the 4th power is a positive, times 2 is a positive. I don't care about the coefficients. I only care about the positive and negative. And then a negative cubed is a negative times a negative is a positive. Oh, not interesting. No negatives again. All right. Yeah, no sign changes are negative. So let's make a chart one more time. So positive, we had 2 or 0. Negative, we had 0. So it could be 2 positive, no negative. Could be no positive, no negative. Well, we need 4 total. That means 2 imaginary here, or it means 4 imaginary there. How could that work? This one right here, that is no positive, negatives, doesn't hit the x-axis over there, no positives. That would have 4 imaginary. How about 2 positives and no negatives? That would be, let's see, like that. Yep. That is 2 positives, no negatives. Would have to have 2 imaginary. Okay. One more quick example. Let's say you went through it and you got, let's say it was a x to the 5th. So you have 5 roots. Let's say we got that. Let's say with 3 sign changes, so for positive with this 3, or decrease it by 2, get 1. Let's say negative, there were 2 sign changes, or decrease it by 2. So now you got all these combinations. 3 with 2, 3 with 0, 1 with 2, 1 with 0. It's like making ordered pairs, isn't it? 3, 2, 3, 0, 1, 2, 1, 0. So let's make a big chart. So here we go. 3 with 2, 3 with 0. 1 with 2, 1 with 0. And then since you need 5 total each time, fill in how many imaginary? Well, none. I need 2 there. There's 3, so I need 2 more there. I would need 4 there. Okay? That's it. All right, so I think that should help. Hope you guys have a great weekend. Stay safe. I'll post this on YouTube in just a few minutes. All right, bye-bye.